All right, before we start going over this, let me ask a question. How many of you have ever been told when you multiply a number, it always gets bigger? Okay? That's not always true. If you multiply a number by 1, it stays the same, correct? If you multiply a number by something bigger than 1, your number gets bigger, correct? I am multiplying these whole numbers by something smaller than 1. That means my answer is going to be smaller, then it's going to get smaller. So for example, I have 2 multiplied by something less than 1. 38 hundredths is less than 1. Which means 2 is going to become smaller. Your answer should be less than 2. Your answer here should be less than 4. Your answer here should be less than 3. Your answer here should be less than 4. Because I'm multiplying by something less than 1. If you multiply a number by 1, that number stays the same. If you multiply by something greater than 1, that number gets bigger. Smaller than 1, your product gets smaller. So my product is going to be smaller than each of these whole numbers. So if this first one, you got a product of 2 or greater, then there's a mistake somewhere. On the second one, if you got a product of 4 or greater, then there's a mistake somewhere. On the third one, if you got a product of 3 or greater, you have a mistake somewhere. And on the fourth one, if you have a product of 4 or greater, you have a mistake somewhere.
Yep.
So look at your paper for that first. Now I will show you how to do it using the algorithm, but on tests and examples and stuff like that, they may give you the graph and tell you to shade it incorrectly. They may give you the graph that is pictured and ask you what problem that represents, just like what we saw a moment ago. You know what I'm saying?
Yeah.
Brett?
So, like, say if you did 2 times 38 in the decimal, it should be no higher than, like, say if you got, like, can the number be higher than 2? But not as in still decimals.
Okay, the value is going to be less than 2.
Yes.
The value of that number. Now, you're going to have numbers with decimal points.
Yes.
So, the number behind the decimal point may be greater than 2. Yes.
Okay.
Okay, but we're talking the value. The product of the number is going to be less than this factor. The product of the number is going to be less than this factor. Yes, ma'am?
Like, so before the point, it cannot be like anything but 2.
Good. Your whole number is not going to be, it's not going to have a 2 in this place. Your whole number has to be 1 or 0. Your whole number is going to be 1 or 0. Whole number, the number in front of the decimal point. Now, as Gage showed, you can do repeated addition. And that's fine. But like I said, you have to be able to recognize the picture, if the picture's there. On an assignment or a test that you get, I'm going to put the picture there. And you're going to have to be able to complete the picture. Because that's the way I want it. That's why, Hira. That's the way I want it. Don't argue with me. I know he didn't. the first thing you should have done is
shade it in.
drawn your hundreds squares. That is the first thing you should have done.
Yeah.
If you didn't draw your one hole where each of these individual little squares is worth 1/100th. Sorry. If each of these little squares isn't worth 100th. So if you didn't draw it to begin with like this, then you have some errors in there to begin with. So that's what it should have looked like before you even began. So that's what it should have looked like before you began. Now this first problem asks you to have two groups of 3800ths. Two groups of 3800ths. So all I have to do is I've got crayons and I'm going to color in two groups of 3800ths. Here I'm going to color in. Now if you pay attention and you've listened in the past, you'll find out that this is 1/10 or 10/100ths. So that's 10. That's 20.
That's 30.
That's 30. And then we're going to color in 8 more. And that'll give us one group of 3800ths. That is my one group of 3800ths. Now I color in a second group of 3800ths. Ten, 20, 30, and then 8 more. That is my two groups. Yes.
You forgot to color in the two.
No, I didn't.
No. Right there.
These two here.
Yeah, she only did that on the video because that's just
It makes it easy. I could have taken these two purple ones here and moved them over.
Is it fine if
If you did it that way, that's fine. If you did it that way, that's fine. Now your product, this is our two groups of 3800ths, or 2 times 3800ths. Your product is how many hundredths are shaded in. How many hundredths are shaded in? Tucker.
76.
76. So your product of this problem is 76 hundredths.
Oh, I got it right. I got it.
Your answer is 76 hundredths. Is it less? Is that less? Is our product less than 2? Yes. Because I have a 0 as my whole number. Let's look at the second one. And if you got it right but you did it differently, you're not doing it correctly. It needs to be a one whole square. It needs to be 10 by 10. That's how you show one whole. Our second problem is 4 times 24 hundredths. 4 times 24 hundredths. So this time I'm just shading in 24 hundredths 4 times.
So many times.
So 1, 2/10, so that's 20 hundredths, plus 1, 2, 3. That is one group of 24 hundredths. I'm going to have another group of 24 hundredths.
You put in 25 hundredths.
Yeah.
Did I do 25?
Yeah.
Yep.
All right, we'll color that green.
Yeah.
That's 10, 11, 12, 13, 14, 15, 16 hundredths, 17, 18, 19, 20, 21, 22, 23, 24.
More.
So we have two groups of 24 hundredths. We have 10, 20, 30, 40. This would be 50, and then I'd subtract the 2. So 48 hundredths would be my answer. Your answer would be 48 hundredths. Oh, 4 groups. I'm sorry, my bad. My bad. Thank you. 4 groups. My bad. That's 2. Sorry about that. 22, 24. 10, 20. All right, my bad. My answer here is less than 1. If my answer was 1 or greater, then that whole thing would be shaded in. But I'm less than 1. So 1 whole has 100 hundredths. 100 hundredths equals 1 whole. So I have 100 minus 1, 2, 3, 4, which gives me 96 hundredths. Yes, sir.
Mr. Matordo, is it okay if we do the way that we did in the video, finish filling up the row?
Yeah, that's kind of what I did here. Yes, yes, sir. And on the way to Coker. Let's look at these last 2. This one I'm going to have 3 groups of 21 hundredths. That's 21. Hey, I don't know why they're talking. Go around the other way, DeAndre. That's 21.
Are we on the third one?
Yep.
And 21. So that's 3 groups of 21 hundredths.
Yeah.
Which gives me a total of what, Regan? I can count them. 10, 20, 30, 40, 50, 60. Count. 6,300 hundredths. Good. So this is one way to solve problems like this. It's good to know more than one way. Rhett, it's good to know more than one way. Why?
Because if you know multiple ways and there's like one way that you keep says no, you do not do this, or if like you or if you just get tired the other way, or if you just forget it, it's just good to always have Plan B.
Good. You always need multiple ways. Plan B. This allows us to check our work. This allows us to know how to do it in case your mean teacher says, no, don't do it by repeated addition. No, don't do it by the standard algorithm. You must do it by drawing this grid and solving it that way. In whole numbers times decimals. Whole numbers times decimals. I'm probably not going to take it out past the hundredths place. And so really you can think of it as money. So if you bought 4 pieces of candy, each piece of candy cost 13 cents. How many cents would that be? So that'd be real easy for you to figure out using money. So let's look at this one. Remember, we're being kind. Part of being kind is being respectful to your teacher. So this one has 4 groups of 1300ths. So I know each row is 10 hundredths. Plus 3 more is 1300ths. This is 7 hundredths. That makes it 10 hundredths. 11, 12, 13. That's my 2 groups of 1300ths. That's 4. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is that right? Did I color that correctly? Yes. All right. And here's our last group of 1300ths. Here's 10, 11, 12, 13. So this gives us 1300ths as well. So if I were to ask you, Najane, what is the answer to 4? What is the product of 4 and 1300ths? 10? Okay.
52.
52 hundredths. 52 hundredths. Now, if you wanted to check your work, you could always do the repeated addition. I haven't shown you how to do the standard algorithm yet, but multiplying whole numbers and decimals is really pretty easy.
Yeah.
Actually, pretty much anything we do is pretty easy. I'm just
Turn on
saying.
that one, Buster.
So let's look. After we come back, we'll look at some others that may go greater than 1 whole. Thank you for watching. Be kind to one another. Boom shakalaka. Love you all. God bless.
Bye.